on this computer. All right, we started to record as promised. Sorry, they will miss first 15 minutes. Emily, do you have something that you would like me to comment on, something?
I just have some questions about some of the homework. Not like
Go ahead.
solving them, but I had one question about like the answer format. This was one of the review questions right here. The way that I had solved it, they like took out the fraction. I can show you here. I wrote down how I had the answer, and then what the book has here. And I was wondering if it matters for you which
No,
form.
not at all.
Okay.
They factor it out. Don't worry about it.
Okay.
So generally, I mentioned that in one of the videos.
Okay.
If you have dilemmas, if your answer is the same as the one in the book, just graph them both to the calculator.
Okay.
And you'll see that. Actually, one of the things that I postponed, and I should do it as quickly as possible, is in none of the videos I showed how to use calculator. So in the last section, 8.8 that I will record today or tomorrow, I will also include that in the beginning. We don't need very much about calculator, but just how to calculate definite integrals using calculator when they cannot be calculated otherwise, and also we will use it for limits. So that's coming today or tomorrow. And then someone asked me last time to post things a little earlier, so not to wait like last minute, like when will the quizzes and homework be. So I don't know if you looked at our Canvas page. This morning I posted everything for week 2. So there will be quiz 3, quiz 4, another homework on Monday, and basically that's now we are really next week we are getting ready for exam 1. So exam 1 is coming on Monday, July 2nd. So we already need to start thinking about it. So look at the practice tests that have been posted there. So your test will be fairly similar. So same level of difficulty, same number of problems.
Okay.
I hope everybody scheduled already the exam 1 in the appropriate center. If you did not, I would really recommend that you do it as soon as possible so that they don't run out of options. If you have any troubles understanding my instructions there, let me know. I posted the link, so it should be okay. But as I said, if there is something missing, let me know. Let me see if Jonathan wrote something. I understand, okay. Do we have someone else? No, just 2 participants, okay. Emily, would like me to do something on the board? People commented a little bit about the volumes, like that was a little bit, it really happens that actually they are a little bit lost through the cracks.
I noticed that like with headphones in, then I can turn it up louder. But if I just try to play it through my computer, like if like the refrigerator is running, I can't hear.
Oh, I mean my videos?
Yeah.
I see. So on headphones it goes better?
Yeah.
Let me tell you, I checked, someone commented that Tuesday. What happened is actually I had the back camera for first 2 sections. Okay. And then I noticed that that's on the edge of being decent. So I asked for a different camera. So from 8.3, I think sound is much better.
Oh, okay.
So if it's not, let me know.
Yeah.
I can re-record some of them, I'm not avoiding that option. But, I hope that they are useful. Are you finding videos covering most of the material, or?
They're great, yeah.
Okay, oh good.
Yeah.
Okay, thanks. Okay, good. So yes, about the volumes, what is the problem? Problem is that professors in in Calculus 1, generally that's toward the end of the course, so actually it's not even planned in the curriculum to cover it too seriously, maybe to mention it. And then professors in Calculus 2 assume that in Calc 1 it's done, so it's really no one has a section that says volumes, and I also kind of sneaked it in through exercises, but I hope I gave you the main reasons, why is it that way, what are there are 2 formulas, and just you need to know which one is applied when, and to adjust when things are not toward the X but toward the Y. That's what I posted on our discussion board. But as I said, maybe you can do one of the problems.
I see, you meant volume, like solving volume. Yeah, in Calc 1, it was like the last 2 sections, they squeezed it in like the day before the final.
Exactly. Yeah. We are aware of that, but
Yeah.
I don't know how to fix it. Calc 2 is also busy course. We don't have time now to start with those two sections. Then it would be at the expense of other.
Yeah. I had one question about, it was one of the ones, oh, number 44 here, because when you solved it in the video, you get this, the arcsecant, this one, and then the paper like that you gave us, the notes, has a different answer, and I did put them both in the graphing
They are the
calculator.
same, by one. They
So I
differ.
had different graphs.
Yes, but they differ by one.
No, I mean, it was like, this graph picks up where there's like a gap. Maybe I just didn't use the graphing calculator, right? But like, when I graphed the one.
Let me see. So what is the one that we got? Yeah, let me get it. And then let's see.
I see too.
So from section
Yes.
8.1, we are discussing problem that looks like it has two different solutions. Let me see.
Yeah.
Yes. Okay, and hold on. Yeah, thank you. So it is number 48, it says. It's integral of dx over x minus 1 square root of 4x squared minus 8x plus 3. I think someone also asked me that online, and then the result that we got is in the notes was arctan of square root of 4x squared minus 8x plus 3 plus c. Okay. And what did we do in the notes? We got substitution. Then we got dz over t squared plus 1. Looks decent if I didn't make some calculation errors. Force cancel looks good. So this is in my notes. And then on the, so no, this is from notes. What about from video? Can you tell me if you recorded the video and what? Which result? I solved it a little differently because I didn't do that substitution. I just recognize it as arcsecant.
Yeah.
So, so do you have it recorded?
It's arcsecant absolute value of x minus 1, and that's all over 2, like the whole thing.
Just this?
Like the whole arcsecant x over 1 is all over 2. Or I guess you could say 1/2 arcsecant.
Like this?
Yeah. And then there was the absolute value of x minus 1 plus c.
Okay. Yes, and that's also true. All right, so that's what I warned you, that it might happen, that two answers look different and they are the same, or because of plus c, it's okay if they differ by a constant. So let me see. One way would be just to put them in calculator, you know. But I'd like also, and that will help us to have a little preparation for that's hard section 8.4. So I'm trying to compare arctan of this and arcsecant of this. Okay? So let me see. Let me call 1/2, or let me call. Although what I'll do will be probably quite complicated trigonometry, if it's correct.
Okay.
If I catch the error, I catch the error. But let me call this arcsecant of x minus 1, let me call that theta, so that's the angle. So arcsecant of absolute value of x minus 1. And I'll just say here, I'll just work with when x is greater than 1, so that I don't need to worry about absolute value. So what do I know here? How much is secant theta? Because this description says theta is the angle whose secant is x minus 1. That's what arcs are.
Okay.
So basically, how much is secant theta? It's like, you know, a town that lies on San Diego River. What's that town? It's San Diego. So the same thing here. So the angle whose secant is x minus 1, that is the secant of that angle, Do you agree?
Okay.
Now what? Or let's say the following. Yeah. So secant of theta is x minus 1. What does that mean? That cosine theta. So my result here is 1/2 theta. Let me see if I can label that actually. No, sorry. Let me label, might be better. Let me label the whole thing with theta. It might be easier. Okay. So that's theta. So what do I get? Arcsecant of x minus 1 is basically 2 theta. So I know that secant 2 theta is x minus 1. Okay? And the same thing as a minute ago, just now I call it 2 theta and not theta. So what does that mean? That cosine 2 theta is 1 over x minus 1. So I will label a triangle. And in that triangle, this is adjacent and this is hypotenuse. You agree with me? So what then? Then I will have okay. So I will have 2 theta. Adjacent will be 1 and hypotenuse will be x minus 1. So that's the information I have. Is it better to work with theta? It doesn't matter. Now what? I want to see how much is tan theta. Because tan theta should be, if this is correct, if this is the same angle theta, if that's the same as this, tan theta should be square root of 4x squared minus 8x plus 3. And then what? Tan theta equals, what would that be? It would be 1 minus cosine 2 theta over 1 plus cosine 2 theta. That's fairly well-known identity. Why is that? Because 1 minus cosine, no square root. And of course, that's where I said you need lots of trick skills to see that. I'm just trying to kind of check actually for myself. Why? Because 1 minus cosine 2 theta is 2 sine squared theta. This is 2 cosine squared theta. 2 and 2 cancel. When you square root it, in the assumption that everything is positive, you get 10 theta. So what would that be? Square root of 1 minus, how much is cosine theta? 1 over x minus 1 over 1 plus 1 over x minus 1, which is square root. If I subtract, multiply by x minus 1, we get x minus 2 over x. Okay. So tan theta is square root of x minus 2 over x. What would that be? So that I should get that tan theta is, how much is it? Just almost the same. Let's see. Arcsecant of x minus 1, secant 2 theta is x minus 1, cosine 2 theta is 1 x minus 1. Tan theta is this. Then what happens with this angle? Let's see, arctan square root of 4x squared minus 8x plus 4 minus 1. It's arctan square root of 2x minus 1 squared minus 1, which is arctan square root 2x minus 2x. Oh, that's the same thing. Is that right? No, x minus tan theta. This is, yes, you see that x minus 2 is there, x is there. So so all this is called theta with 1/2. So 1/2 is called theta, arcsecant of x minus 1 is 2 theta. So secant of theta cosine of 2 theta is 1 for x minus 1. Choose what? Let's. Oh no, we don't have calculus.
I have one.
Let's say, oh,
Yes.
yeah.
I have
Alright.
to put them into.
Let me see. So 10 to the minus 1 and 1/2, 1 minus. Okay, so when we graph. Okay, so what's the problem?
If you look,
See?
actually,
Did you graph both of them? Yeah.
and then if you look at,
Let me see. Window. Let me go -3. -3 to 3. And y minus 1, like -2 to 2. Let's see just one of them. That's one of them. And what is the other one? Okay, because this is very easy.
let me see, which one did you use? This one we just did. And this is the other one.
Oh yes, but they're the same thing.
It is.
Yes, they just differ by 1. Look at this now. Let me now go y equals. Second one is 1 lower. Let me now second insert 1 plus. Let me graph it now. When I raise it by 1.
Why doesn't it doesn't have the?
Because of the because of the scaling. So y maximum. Let me just zoom in windows. So let me go window between like negative, wherever that happens between 0 and 1. And let me go y minimum between 0 and 1. Window range. Window minus 0 to 1, 1 to 2. This is 0. Maximum is 1.
Yes.
Or y minimum is 0. It's 2. Let me go. All right. So here is the graph in this window. Let me go into y. Cover this minus 1. Get this. You know, let me see how let me graph go. No, there is error in one of them. I will check both so that we don't now spend the whole time discussing this. One of them is wrong.
Okay.
So, and I don't know which one it is. Actually, they both look like straightforward solution. I will check and I will post the information. Yeah, there must be something because I also see here they didn't end up being the same thing. Let me see. Did I do the
Looks
same
like put it in the calculator wrong. That's my only. I mean.
What's it? Oh, 10 to the minus 1 square root. Yes, I entered this. So 10 to the minus 1 mode is good. So y equals 10 to the minus 1. 1 half. Oh no. You enter in trouble.
Okay.
Here is the reason. How do you enter into calculator? How do you enter arcsecant?
Well, I thought it was 1 over.
No. Who needs to be placed in the reciprocal? Angle or the ratio? A ratio. So you should have entered this the following way. 1 half cosine to the minus 1 of 1 over x minus 1.
Okay.
Make sense?
Yes.
So,
That does make sense.
okay, good. I could have saved myself from having calculation if I just lost it, right? Jonathan, we completely lost you. Are you there? Okay, you didn't miss much, actually. This was just discussion why something didn't match. All right, but did they come up similar?
I'm still gonna. I think now they match, yeah.
They match? Good. Then I don't need to post anything.
Sorry.
Yeah.
But that's important because now I know how to do that, right?
Yes, because, you know, because what? If secant, because you want 1 half secant of x minus 1 degree. So that means if I call this angle theta, we know that secant of theta is x minus 1 degree.
Mm-hmm. Yeah.
So cosine of theta is 1 over x minus 1, and you reverse that.
Got it.
So you reverse the input now. I think that's not the same. No. Okay, good. Any other questions? How is integration by parts? That's what you didn't have in Calc 1. That's a new technique. I don't know if you looked at it and if it makes sense. And
yeah.
You know, it's much more limited technique. So if I would say like 100% of integrals, 90% substitution, 10%. Integration by parts is a limited technique only for certain types of functions. Like you notice power and sine, power and ln. So those products, and then a few more, but generally less general technique than substitution. But easier to apply because when you recognize who is who, you just run the machine.
Yeah, I feel like it's pretty straightforward. I guess the hardest thing probably would be to recognize
who is who.
Yeah.
Generally, I don't know if I think I wrote that somewhere in the video.
Yeah.
There are functions that kind of really insist on being U or V, and some that are flexible. Power function looks who's in the company, so it can go both ways. But for example, sine, cosine, e to the x, they don't care because derivatives and integrals are equally complicated. ln and other arcs insist on being U. And then power could be both. So that's basically the idea. And then particularly, you should pay attention to that one problem when there is that looping, where you don't simplify integral, but ends up being the same thing, and then you solve for it and you get it. So,
yeah.
So that's interesting.
Tricky, a couple extra steps.
Yes, yes. And, philosophy is always in all these integrations. Integral gets simpler and simpler and simpler until it falls into the table. Here it doesn't, stays the same, but gives you the information about itself. An interesting idea.
Mm-hmm.
Would you like to discuss something else?
That's all the questions I had so far.
Okay, good. How's your feeling about study groups or anything like that, or you're fine the way things are? Because I try to stimulate people to form some study groups and meet in the Math Learning Center maybe. Because I have class on this campus 11 to 2, so it's convenient for me to visit that group, give a couple of hints, and also there are our teaching aides and instructional associates, so they can get lots of help. You can get lots of help, but if you don't need it, maybe if you're perfectly happy the way things are, that's fine. So yeah. So that's what I wanted to start in the discussions. My plan is to have this meeting every Thursday. I'm going to schedule this room and the Zoom meeting so that we kind of wrap up every week with a meeting here. So maybe people just we have enough questions or things are not so urgent to show up this week, but then maybe next Thursday is actually Thursday before the exam, so I assume that there will be more people coming and more questions.
Yeah, I'll probably come because it's just sometimes nice to just talk about the math. True,
yes, good idea. And sometimes, to resolve one issue takes you an hour. And sometimes that's valuable, but sometimes also it's not. For example, here that little error where you flipped it actually caused, your dilemma, what's happening, why did I get two different results and all that. So big discussion. Yeah. Okay, let's see if Jonathan has something. Okay, I can see the part of the board you are working now, 1034, that was 6 minutes ago. Is it any better? Shall I make it a little closer maybe? Or you cannot see it from me? Is this readable? Okay, good. So I'd like to know where to put my laptop so that you can... how is the sound from my laptop? Is it okay? You can hear me well? Okay, nice. So I might use even this for recording instead of camera. Jonathan, would you like to discuss something? Any particular questions? Let me see. Just missing some of the board on the left. Okay, then I'll go. Board on the left. Okay. And then I gotta right if this is not too far. I think that did. Yeah, actually, I know what I did when I did videos. I should actually put a line. Here's the left border. Here's the right border. So I should keep myself between these two limits. Okay, so now I know which part you can see. But now I don't get out of that window. Jonathan, shall I erase this? Do you need something from there, or shall I erase it? Because this tree calculation is really what we need necessary. All right. Okay. Okay, perfect. Jonathan, any particular questions? Emily?
If we have nothing else, we could do the 86 and 88 from 8.1 homework.
Okay.
Since I don't know, there's no answer in the book.
Let's do 86. So what's the problem to do? Is that the volume?
But yeah, it's both. They're both volume.
Can I see? I didn't bring the copy. Should do it next time. Yeah, 86. Sketch the regions when the disk method is used and when the shell method 0 to 4 pi y dy. Okay, integral between 0 and 4 pi y and dy. So what is this integral about? So what is the region? So you see, here is locating y as a function of x. This is the reverse story where x is a function of y. So function is x equals pi y. So basically, we are looking at that region this way, horizontally. Limits are 0 to 4, so those limits are here. And then x equals pi y, that's straight line. And where does it end? It's easy. When y is 4, x is 4 pi, so it's kind of stretched like a triangle. So it looks like this. So this point A is 4 and 4 pi. How did I get 4 pi? I just plug in y is 4. Then 4 times pi is x corresponding, so it's 4 to 4 pi. So that's your line, x equals pi y. And this is your region. Everybody okay with that? Now what? Now that region rotates, if I want a disk method, that means you look variable here, so your variable is y. What else? Axis of rotation is also y, that's the disk method. So if a variable, independent variable y, axis of rotation y, that will be disk method. By the way, what will happen? This will go around, so you will get a cone. Like this. Can you see that cone when it rotates around? And there's the volume that you will get. So what is the formula then? So formula says V equals integral between 0 and 4. You take your function, x equals pi y. You square it, dy, that's it. That's the same as what I did in the lecture. The only difference is I did it for the vertical region, everything is in terms of x. Here, everything is in terms of y. So they just switched their roles. Yeah.
Is there a pi before the integral?
Oh, yes. Sorry. There is a pi integral of x squared, yes. Thank you. And what would that be now? The trivial. I can split this pi integral 0 to 4 pi squared y squared dy. Separate that. Pi squared goes out, we get pi cube, y cube over 3 between 0 and 4. That's it. Now we just plug it in, so we get what? 64 pi cube over 3, and this is the result. Integral was easy. The only thing is to do the setup and then visualize it. Everybody okay with this? Good. Now let me erase this. And now do the shell method. So what will happen in the shell method? Let me write it here. Shell independent variable is still y, but axis of rotation is x. So you rotate around the other axis. So what will happen? Generally, this will make a cylinder, and this will make a hole. So it will look like this. Imagine cylinder where this is drilling the hole. So here as well. So that's the cone with a drilled. No, I mean cylinder with a drilled cone. Imagine when this rotates, makes a cylinder. When this rotates, drills a hole. So how do I get the volume of that object? So we'll get a V equals 2 pi, your limits are the same, 0 to 4. What is the only difference? So it's not pi, it's 2 pi this time. And then what? We get both x and y. So when I did in the video, it would be 2 pi x f of x dx. But this time it will be 2 pi on the side. And here it will be 2 pi integrals of x. Now it's y, g of y dy. G of y is that function. G of y. So what would that be? You get y. G of y is pi y dy. That's it. So what would that be? 2 pi squared, because this pi and this pi gives pi squared. Integral of y squared is y cubed over 3, 0 and 4. And you get what? 2 pi squared times 64 over 3. That's it. So it is straightforward. Integrals were easy. Just actually to adjust your knowledge so that, and that's what I mentioned in the comment in the discussion. Memorize the formulas with the x version for vertical regions, and then I just adjust them and say, all right, you see what I did. This is what I memorized, and then I said, all right, x becomes now y, f of x becomes g of y. Limits are the same, whatever the variable has limits, and that's it. Let me see if Jonathan had some questions or comments. Just me, no, thanks, perfect, no question. I'm still looking throughout the assigned homework. Okay, very good. Jonathan, so again, whenever you have questions, whenever something's troubling you, just post things on discussion, send me an email. Let's be proactive, especially this week when we are kind of establishing the methodology. Because next week we'll start getting nervous about exam 1. So this week and this weekend, just open everything that needs to be opened. If you have troubles with algebra, do algebra. If you have troubles with trigonometry, do a little bit. Inquire either from me, from Math Learning Center. So let's do the things. Okay, Emily, you think of something else?
Would you want to do 88?
Okay.
I wouldn't mind.
Why not? Why not? Let me just
look at it out of the book.
So 88, let's class. Let's say 88. Consider the region boundary graphs y plus cosine x squared, sine x squared. Find the one behind the one, the region about the y-axis. Okay. This is a little trickier, actually, just to kind of get oriented. So y equals cosine x squared, and y equals sine x squared, and x is between 0 and, what is it, square root of?
Root of pi over 2.
Root of pi over 2. So generally what happens, if you draw these two graphs, you know that cosine is at 0, cosine is at 1, and sine is at 0, and cosine goes down. And the question is, what happens at the end? At root pi over 2. When you plug it in, cosine of root pi over 2 squared is what? Cosine of pi over 4, and that's root 2. And when you plug into the sine, you get the same. So generally what happens is cosine goes down and sine goes up like this, and they meet at exactly the same point. So that's your region. And that's it. So here's your region. And you rotate around the y-axis. So what would they do? You will do shell or this method?
Well, the way you
Who's your variable?
X.
Who's your axis of rotation?
Y.
Y. If they disagree, that's a shell method. It's very easy to decide.
Okay.
Make sense or not?
So why did you shade in the, because the inside part, like along wouldn't it? Oh, because it's
Between them, it says between the graphs. So X goes between here and here, and then between those.
Okay.
Make sense?
Yes.
But anyway, I look at the region vertically. So then what value will be? What will happen? Basically, a red graph with a shell method will make all this value. A green will drill the hole. So what are we going to do? We will go integral 2 pi. Integral between 0 and root pi 2 x f of x dx f1, let's say, minus 2 pi integral root pi over 2x f2 of x dx. And that's, or we can get them together, of course. Do we need to? Doesn't matter. Integral from 0 to pi over 2x cosine x squared x. Oh, why don't I get them together? It's easier. Cosine x squared minus sine x squared. It's cosine is above sine, so cosine is building the mass, and sine is bringing the whole. When you rotate it, you'll get something like this. Something like this, and this will be your mass. So red is making the mass, green is bringing the whole. And then what do we do here? It's very easy to solve. What is a good substitution? The one that's derivative ready, so that's what u equals what? X squared. If you do u equals x squared, then what happens? du is 2x dx, and that's exactly what we want. Here is x, here is dx. I'll even borrow that from outside, and that will all be what? Pi integral cosine u minus sine u. 2x dx is treated as a package as du. What should I do? Not to forget, are my limits 0 to pi over 2, or I need to adjust them? Do I need to adjust the limits? So limits are what? 0 stays 0. When I square root pi over 2, I get pi. That's it. Now and I never look back. We said, don't try, don't think of x, anything. I can erase all this and just finish my integral. So what would that be? Pi times integral of cosine u is what? Sine u plus cosine u, because integral of negative sine u is cosine u between 0 and pi over 4. At pi over 4, it will be root 2 over 2, and root 2 over 2, this will give me root 2 minus. At 0, value 0 plus 1, which is what? 3. So basically, these problems really involve very simple calculations, and but just setup is what we need to do. And then maybe it was part C, where you do the disk or rotate around x-axis or not. Did they ask? No, they just want y. That's fine. So it should be. All right. So that's where we finish our first Zoom section that's also on the ground. So next Thursday, we'll do the same thing in the same room. And then if you find it useful, then you can just come or either follow us on Canvas or just watch it later. So here, let me stop